Hiding inside of our Git repository are what are referred to as Git branches. So this project has now been branched out into 5 branches after the master branch. So the way to think about that is it's just like branches on a tree. So it grew, the project grew, and then it's gone off in a new direction. It's gone off in a new direction. And at each one of these, I'm using branches not as a way to explore different features or to try out different things in a project, which is how branches are commonly used, because you're working on something and you go, I wonder if I try this, is it going to work or is it going to break my project? Well, make a branch, try it out. If it works, merge that back into the main one. If it totally blows things up, then just abandon it and go back to the main one and keep on working. No harm, no foul. And that's one of the great things that you can do when you're working with Git. But I'm using it now as a way to capture each of the steps that we use as we build out our project file. So we can see just one step at a time, do something and go, okay, that works, and then create a new branch to explore the next level of functionality, a new branch for the next level of functionality. But it also means that everything is now contained right here. So if I look at this, we'll see that under the start file, it's the original file that we began with last week, where it doesn't really do anything. The stuff shows up. You can click on the buttons, nothing happens. You can type text, nothing happens. And it's a pretty sad event because you're trying to do something and nothing happens. But that's why it's the starting file. Now, if I jump between files, we can look at the README. We can see, okay, that's what's there. But now, realizing I have these additional branches to work with, I can click over to my step 1 branch and see that, oh, look, my README has some different instructions on it. If I jump between files and look at the start file now, we'll see that the start file, write story actually has something in it. If I run this one, it might actually just work. And wouldn't that be really cool? And knowing that's step 1 and there's additional steps, I can look and go, oh, wait. Step 5, what's that do? Oh, look, it verifies that the user put in some content into the form. It controls the display of the different panels with the warning panel, input, output. We can reset the form. It's a fully functional, completed version. It's butt ugly, but it works. So everything is here. The tricky part is now, how do I gain access to those individual pieces? But if I look at my README files, we'll notice that there's some information here about how to gain access to a specific branch. And that's what we're going to look at next. Is we will clone a fresh copy of this repository, and then we will check out the branch that we want to start playing with and look at and see what code is contained within that particular branch. So then we will find out how we can do that. But as you can see, the command is git checkout, and then we have the name of the branch we're trying to check out. So then we have checkout step 4, 3. Now, it would have made it really easy if it said git checkout in step 1, 2, 3, 4, 5, but I elected to make longer names so then when you look at the list of branches, you have some clue as to what those branches are trying to do instead of just having short names, but then you'd have to click on the branch and then read through the code and go, oh, that's what's different this time. So the branches are a really, really, really powerful feature of working with a version control software like Git. And I would encourage you to start exploring it. Now, the good part about working with branches and doing things with it is it's pretty forgiving. You just type in git branch, the name of a new branch that you want, then check out that branch, and you're happy as a clam. And we'll work through a little bit of that process tonight to try and come up with an understanding of how all of it comes together. So the first thing that I want to do is I want to clone a fresh copy of this project. So to clone a fresh copy of this project, doesn't matter whether I'm looking at the master branch page or any other branch page, to clone the project, I'm going to grab that. But just for keeping things clean, I'll just be on the main master branch. I click the Clone Copy to Clipboard button. And we can bop over to Terminal. You need to figure out where you're going to put it. I would encourage you right now, just dump this onto the desktop. If you already have your project on the desktop, then you may want to add a folder and then put it into that folder, or go to the Documents folder and save it there. Because right now I can see that currently I'm at the root level of my computer, so these are the directories that I have access to. So I can navigate to a new directory, CD, and I am going to just type in desktop. Because there's no other DE, if I hit tab, it will complete that for me. So when you're working in Terminal, letting Terminal autocomplete names is a really nice way to not get all kinds of hate-filled error messages from Terminal, which I'm sure some of you, myself included, have experienced far too often. The more you can just let it autocomplete for you, the better off things are. So now I'm on the desktop, just that I'm at the desktop. And now I can just say git clone and then paste what I copied off of GitHub. Hit return. And we can see it now typed in, or gave me some feedback that it finished putting it all there. And then CD MadLibs. So now I'm in the MadLibs directory. Now that we've cloned the class repo to our computers, so now we have a local copy of it, navigated into that folder, I can list the files that are there. We can see there's the README and there's start. What we want to do next is to check out a branch, because currently, if I just type in get branch, it shows me that I am on the master branch. But I don't want to be on the master branch. I want to be on the step 1 branch. Now, I don't have my branch names just committed to memory and all set, ready to go. But back on GitHub, I will see that if I click over to step 1 and look at the README, not only did it have instructions on the cloning part, so I didn't even have to click the clipboard, but I have this other line where it says git checkout. So I'm going to check out a branch, and it's step 1 dash using inputs to write story. Okay, copy that. So now here in Terminal, you can paste git checkout step 1 dash using inputs to write story. When I hit return, it now gives me a new message, and it says branch step 1 set up to track remote branch from origin, switch to the new branch, which is the part I really care about. Now if I type in git branch, it tells me that there are 2 branches, and it puts a little star, and on the default coloring, it colors the active or current branch green. I have successfully navigated and checked out a different branch. So I'm no longer in the master branch, where originally we had the master branch, but now I've checked out and I'm using this other branch. I'm going to look at these files using Sublime. And when I look at the files in Sublime, I will see that I have a file, my program can actually write the story. It can work. With my file open here, one thing that I'm going to do is I am going to use the console so I can see that it's tracking what is going on. So here is my file open. It's waiting for a first name, my color. So if I can just type in John, Rad, Mars, and submit my answers, we'll see that now something actually happens. Where the original master file that you started with The functions were all there, the variables were all there, the event listeners were all there, but it didn't actually do anything because the pieces weren't connected together. And that's what we're going to look at now, is how to connect those pieces together so that we can see by filling in the form and hitting submit. And if I type in a different name and submit, we'll see how it updates what's in that form below. But eventually, we want to get to the point that we're changing the class names on these different divs, so then we make things show and hide, so we get rid of things as we need to, so that we have a better user experience. That's what we will be aiming for in later versions of this file. These items with numbers listed after them commented at the beginning are both things for you to try, but also if they have a number in front of it, it specifies one of the handout files that's in handouts on the GitHub site that will give you some tips on how to do those different things, how to change CSS, how to capture the enter key, how to set focus, how to change the cursor, preventing empty inputs. These are all things that are hidden or plainly obvious in those 30 or so helper files. They're all real short files that just do one little thing, but they give you some clue as to how to do different things using JavaScript. And we will be referencing them throughout the duration of the semester because they do all kinds of core fundamental topics and concepts that we need. The only change in this file from the starter that you began with is in the write story function. You're given an empty function, and this is now one way to handle the problem of grabbing the input and doing something with it. Now, a few words about how this is put together. You could theoretically just say the story.innerHTML, where you're setting the contents of an HTML tag, and then it would be equal to a bunch of stuff. So it'd be like this plus, so all kind of the stuff in quotes in yellow. It could do all of that. But the problem is by the time you have about 10 inputs or 20 inputs and all kinds of stuff, and you try and put that in one big long chunk, it fails. It's maybe a 60% success rate. So I could let you try, and if you're one of those lucky 60%, great. But if you're in that 40%, it's super annoying to know that there must have been a better way and your instructor was too mean to share it with you. So I've learned the hard way that we need to come up with a little better way of doing it. By adding a piece at a time, we're able to construct something that doesn't freak out. It seems to be tied to line length, because if you notice, these are now all relatively short lines. But if I put this all together, it becomes a really long line. And then the JavaScript seems to freak out because there's all these different quotes and then pluses and other punctuation that just wreaks havoc with it. So it just doesn't work very well. But we find if we break it into pieces like this, it does seem to work with a much higher percentage of success. Now my preference for doing it is to kind of do one value per line. So we start out and just make a temporary variable. I called mine finished story. You could call yours whatever makes you happy. And we just set it equal to an empty string. If we don't set it equal to an empty string, it initially will render out as undefined. And then it will actually say that on the screen where it says undefined. And you're like, well, that's ugly. You don't want that. So it's good to give it a value to begin with. So we give it a value of emptiness. Because even though it's empty, it's just two quotation marks, nothing in between. Even though it's empty, as far as the computer is concerned, it's a full string. It's just as rich as the next one or this one. So it's plenty happy. And then we take finished story and we add to the end of it using plus equals. And then we put some text, plus sign, and then I take first name and grab the value of what is inside that form. Now this is assuming the user typed something in, but we're not checking to find out if that was the case or not. So if I don't enter in anything, it will still write the story and we'll just have all these big empty spots and it will look weird. So if I don't write my story and just hit submit, we'll see kind of looks the same, but if you read it, there's words missing, or here you can see it was trying to put a name in because now we just have comma space period. Well, that's stupid. That doesn't look good. So we need to grab the value of what gets entered in the form. And we'll review that process in a little bit, but let's first worry about writing our story. And then we move to the next line to grab the next input field. So we add to what was already there, we add some more content. Now you will notice, if you're paying attention, that not only can I use letters, but I can even put HTML tags in here. So I have a paragraph tag. I have a closing paragraph tag. So I can put a limited subset of your HTML tags inside these quotation marks and it will work. So this, when I run it, gives me 2 paragraphs, which works out pretty well. So I add to it, and then I take the story, enter HTML, and set it equal to finished story. And that is how our write story is going to function in the beginning. We're going to add a little bit more to it when we start checking to find out if the user followed instructions and entered in stuff into all the forms, but that gives us a starting point. Moving up into the document, just to rehash a few things about this. So everything that is being accessed through JavaScript has an ID attached to it. So ID first name, ID favorite color, ID input panel, ID submit, ID output panel warning. So these are all just names that I made up. You get to make up your own names. None of these names are hard-coded into the language. They're not special things. But you want the names to be meaningful, so then when you're reading the code, you're not left wondering, what the heck is that? So you want it to make sense. But sometimes people, then they will see the code and go, input panel, output panel, well, what kind of tag is that? It's like, well, it's not. It's just an ID that's been attached to a div. Now, theoretically, if you can design your document so that you can use semantic elements, so actually use tags, and HTML5 added a lot more tags to our vocabulary, so we can often do that, then you can get away with not having to have kind of div ID-itis, where you just put IDs on everything, because you can just reference a specific tag and know that there's only one in your document, so then it makes your code really readable. I mean, there is some advantage to doing that, but this isn't overkill to just have 2 divs here. That's pretty minimal as far as a page structure would go. Now, once you've named everything, we're using query selector to access those and store the reference to those elements in memory. So we tell our document, look for the selector of input panel, output panel, warning, submit, again, first name, fave color, place, the story. So we're looking for these different elements and then storing a reference to them. Now, there's 2 schools of thought on how you name your variables in this regard. One is that your variable name would be different than the name you would put with the ID, so that you're not thinking of, well, it's input panel, so is that the ID or is that the variable? And you don't have that confusion in your head. And the other approach is you make your variable name match your ID. I used to take the former approach, And I found as my projects grew in complexity, it was much easier to not try and have what is in essence twice as many names. So I found it was easier that if I put an ID on something, if I'm going to reference that object as a variable, it made more sense to then make my variable name the same as the ID name of that element. So I found that it became easier, though in the beginning I found it was a little bit confusing when I would look at my code, because I would see the name, I'm like, well, but that's the name of my ID. It's like, well, yeah, and we're using the variable name to reference it. And once I got accustomed to that, it just made more sense, and I didn't have to try and figure out how can I have twice as many names for things, one for the variable and one for the object. And that just, it grew unwieldy after a while. So I gave up on that. Moving on to the next element, we're going to look at the event listener. Event listeners, it's a built-in feature in modern JavaScript that we have access to. If you have to make compatible JavaScript so it's compatible with real old versions of things, though I don't know why. I mean, there are times where you have to do that, but it's usually if you're trying to do something to access old versions of Internet Explorer, it grows grumpy with that event listener. It likes when we use the on method. It's lame. Add event listener is the modern way of dealing with events in JavaScript. So if you work on a project, you find out you can't use add event listener, hopefully there's a senior developer who can steer you to where you need to go. But know that it's a more modern construct of accessing events. Now in this case, it's a click event. So we have different events that we can listen for. We have click events, we have key down events, we have mouse enter, mouse leave. So we have a variety of events that we have access to, and we can track those. And when those events happen, then we make something occur. That's how event listeners work, is by putting the line in the code, it says, I want my browser to listen for and pay attention to when this specific event occurs. When I click on the submit button, that's what this line says. And then when that happens, it's going to call the function write story. Now, if you're confused why it says comma false, and it always says comma false, what that has to do with is the bubbling of events. And there's a specific order in which events happen. As you work through the computer where event occurs, it passes through the different objects in the object chain or the document object model, and then comes out. Right now, 99% of the time, you don't need to worry about the bubbling, but the syntax for event listener requires you to specify a true or false on whether the event will bubble or not. Therefore, in this case, we just leave it as false so that the event terminates here. But it's required, so you can't delete it by saying, well, I'm not using it. No, you have to include it. So you just accept with event listener, you put in quotes what event you're listening for, comma, the function you want called, comma, and false. And that is the core syntax for doing event listener. So we can have our individual buttons listening for events. But we will also notice we have the window listening for the key down event. And the way that works is keyboard events register at the window level. They don't register at the element level. If I'm clicking on something, I'm not clicking on the window, I'm clicking on an element on screen. So I'm clicking on a paragraph, I'm clicking on an image, I'm clicking on a button. But if I'm pressing keys on the keyboard, that's happening at a system level. So everything has access to that. So then we say window instead of the element, add event listener key down. And then we can call our key down handler and figure out what we want to have happen. Now, it says enter key was pressed, but it's any key was pressed. Or some key was pressed. It said enter because in the original code that this started with before I pared it down into its skeletal version, it was tracking the enter key. So that's why it had, in that log statement, it said some key was pressed. The question is, where do you put the script in your document? And in this document, we have the head up here. This CSS is in the top. Now, at better form, it'd be better. We have our CSS as a separate document. It'd be nice to have the JavaScript as a separate document. If we're not including it as a separate document, it's very important that the script is happening down at the bottom. So I've just collapsed the script so we can see here's the script right before close HTML, or close body, then close HTML. And it's important that it occurs down here with my script, because this script is referencing items in my markup. And if those items that it's referencing have not loaded into memory yet, when JavaScript says here, this variable is equal to this item, but if that item's not in memory yet, it will actually come up as that variable is now equal to undefined, because that object does not exist as far as JavaScript's concerned, because it hasn't loaded yet. So when you tell it set something equal to it, it's like, there's nothing there. How can I set something equal to nothing? That's undefined. You're making me unhappy. I'm going to get really grumpy and give you all kinds of error messages in the console. And then your page won't work, and yeah, it's just not good. Now, so we put the script at the bottom. If we take our script and put it into a separate external JS file, which we will be doing down the road, we want to then be linking to that file at the end of our document in the same place where the script exists right now, for the exact same reason. Because if that script tries to load things that are not in memory yet, they will come up as undefined, and that will cause an error. We will learn future techniques on how to keep our script from running or even trying to load anything until it verifies that all of the elements it needs are actually in memory. Putting the script at the end is it's a hack way of saying, well, if I do this, it probably has finished loading everything. But on a dynamic website where it has to make server calls to build the page, where it's loading images and other things like that, it's not uncommon then, if you just put the script at the end and it runs before those things are 100% loaded, that you would then end up with some undefined error messages. So we need to learn down the road better techniques where we will find out, is our document ready? Has it loaded everything it needs to load? And then once it says, yes, I'm good to go, then we let the script execute. And that's what we will move to later on in the course. But right now, the simple hack is you put the script at the end, whether it's an inline script or linking to an attached external JS file. It should happen at the end. Now that we have figured out how to get the first branch working, we're going to step into branch number 2. If I click over to step 2, where we'll learn how to make the divs show and hide themselves, we'll see here's the HTML that goes along with it. And now that I can see that, if I want to check that branch out so I have access to that, I can do that in terminal, and I have my instructions in the README where it says I will use get checkout step 2 toggle classes. So I'll just click copy that, bop over to terminal, and inside terminal now I can say get checkout step 2 toggle classes. When I do that and hit return, it now switched my branch. I can confirm my branch, get branch. Now you don't have to type get branch, I'm just doing that so that we can see. And it now knows that when I'm at step 2, it knows that there's 2 prior branches that exist. There's the step 1 branch and the master branch. So it knows that, so by the time I get up to my step 5 branch, if I say get branch, it will show me that there's master plus all 5 branches, which is really kind of exciting when you're working on a project to know that all of that content is there, even though when I do the branch, we don't see that. Now if I go into Sublime says the disk command has changed, or the file's changed, so I want to reload. Sure. And now it's like, whoa, wait, there's new stuff here that wasn't there in the previous one I was working on, which is the stuff that allows me to make my divs show and hide themselves as my project goes by changing their classes. Inside step 2, the next branch, I'm finally taking advantage of the styles that were provided early on, where we are going to attach classes to these divs through JavaScript. And by attaching the classes are displaynone and displayblock. So we're changing the CSS display property of those elements and how we want to have them show up on screen. Now, there's different things you can do to control the visibility of items that show up on screen through CSS. You can change their alpha or transparency. You can change their visible state. So you can say it's visible or not. But when you do that, all it does is effectively render it transparent, but the object still sits there taking up all of its space on screen. When you say display none or display block, you're telling the element, I don't even want the page to remember that you were there. Go away. Boom. So what the user sees is it doesn't even exist. It's still in the markup, it's still in the code, but as far as the browser is concerned in the rendering layer, nothing's there. Display block says stick it back in, make it take up its full available space. So we're just changing that CSS property of the element. And we're able to do that in the beginning, starting at line 80, we set the initial classes on these items. So we tell the input panel display block, output panel display none, and as a preventative measure, we tell the warning paragraph, we give it a class of display none, so that paragraph goes poof and it goes away. So initially we set their properties. When we call the WriteStory function, we can then change the input and output from the input, which was display block, it becomes display none. The output becomes display block. So that means the output shows up. So now if I reload this page, we'll see that the output is gone. And looking at the code in the console, we'll see the input and the output panel are still there. But we can see the class of display none has been applied to that element. Now, if I take this form, whether I enter anything or not doesn't matter, but if I choose to submit my answers, we will see those classes switch. Now, again isn't coded yet, so it doesn't do anything, so I need to refresh the page. If I refresh the page, we can see that input is display block, output is display none. When we click submit, they flip. So we've changed which class is assigned to that element. JavaScript gives us the ability to attach classes to any element that we want. Switching to step 3, I'm going to go get my get checkout line. Pop over to terminal. Check it out, verify. And I am on step 3, add the enter key and reset. Now to go over to Sublime. And I will see that there's some other stuff going on. Now the reset is just simply flipping the classes once more. But it's also zeroing out the values that go inside the form fields. So I'm going to disable that for a moment so we can see why that's a necessary function. So if I reload the page, we'll see here's the block and none. And now type some stuff in, hit my answers, and we'll see those two flipped. And now if I hit again, we'll see how they flip back, but the form is still populated. So if I'm doing it again, it would seem to stand to reason that we would want to have those form fields clear themselves instead of staying populated. So I'm retelling the same story over and over. Well, that's kind of boring. And I don't want to have to delete it and then type something else in to make it happen. So because of that, it's nice in the reset to tell those form elements to set their value equal to an empty string. That effectively erases what content is inside them. So now if I run the same thing over again, reload the page, you can see it's there, hit again, they're empty. So that's nice. So by setting them equal to an empty string, there's nothing inside those quotation marks, just a pair of empty quotes that says, I want you to be emptiness. That helps to clear it out. So the reset is a pretty straightforward option. All it does is flip the classes back to how they were before. Instead of showing the output, it hides the output, it shows the input once more, and then wipes the value inside my fields. Capturing the keyboard, we already have the event listener, so we have the window listening for the key down event. When the key down event happens, the cool part is every key on your keyboard has a key code associated with it. So we played with this a little bit in programming when we did keyboard input. The same numbers always apply. On an ASCII keyboard, the numbers are always going to be the same. The enter or return key has a key code of 13. So if I wanted a different key to do something like one of the arrow keys, I could just put in its number. So if I wanted left arrow, that would be 37. So every key, every letter, every number, every symbol has a key code associated with it on the keyboard. So we can now track that. But in this case, it's the enter key, because if you're typing things in a form, like our MadLib, then having to take your hands off the keyboard, take your mouse, move over, and then click on the button is kind of annoying, especially when you're testing your project. So I find it's just a much nicer situation to be able to type things in. So I can go to the first name, hit tab, move to the next field, hit tab again, move to the next field, and then hit return or enter for it to take effect. So I find that to be, especially during testing, nice, but also from a usability standpoint, it makes sense to include that type of functionality into what we're doing. Now we could advance it and we could check and find out which panel is currently showing, and then we could make the again button also do that if we wanted. So the again button was tied, so now at this point I could hit return and it would fire off again, but we're not going to add that right now. So now I do have to go and click on the mouse to make it happen once more. So again, conditional if event. Now this event is referring to the event as we see listed here, and that's referring to this event that took place, which is a key was pressed. So when we add an event listener and specify what that event listener is, then depending on what the event is, we can sometimes access properties of that event. Now a mouse doesn't have key codes associated with it, because when you're pressing the mouse, keys aren't being pressed, so you press the mouse. It's a click, it's mouse down, mouse enter, mouse lead, mouse up, but it's a mouse event. A keyboard event has a property associated with it. That property is the key code. So it's the key that was pressed, and it's ASCII character number designation. In this case, enter is 13. When that happens, we call our write story function. One of the more annoying things you can do to your users is to have all kinds of alerts come up, preventing them from continuing on until they have to acknowledge that alert happened. So We've all been on web pages, alerts come up, and we're like, ah, it's so stupid, go away, and it's really annoying. Or you can use JavaScript for malicious purposes and make unlimited alerts just keep spawning to hijack their browser. But that's a very unkind thing to do, so please don't. But what this does is write story happens. So everything is kind of the same here. We have our write story, except that it's been now wrapped into a conditional. So it doesn't actually write the story until it checks to see if the form is complete. And if that's true, then it writes the story. Otherwise, it's just going to send out a message and say, the form was not complete. Now, the way that it knows if check complete is true is it calls the check complete function. The check complete function returns a value. It returns a true or false when it's called. So check complete says, hey, have you filled in the first name? If the first name is still empty, it pops up an alert. If the favorite color is empty, it pops up an alert. If place is empty, it pops up an alert. But if none of those happen, then that must mean all three are filled in, and then it's going to return true. Otherwise, it gives us this false value. So this function returns either true or false. So check complete will return true, or return false, or return true, depending on whether the user has filled in the stuff. Now, if we bop over to the page and take a look at that, if I submit my answers, I get an alert that says name. Okay, fine. All right, I'll type in a name. And we can also see it logged out. The form was not complete. So write story. If check complete is true, it writes the story. Else, it logs out. The form was not complete. All right, fine. I'll put a name in. Oh, it's asking for a color. Fine. Okay. Put a color in. Now this time I'll put in a color. Nope. Still, what's a place? Jeez, it's never going to end. Oh, finally. Okay, now it writes my story. So it's prompting the user to fill everything in. So it's checking that. So we could use alerts as part of this. It's also possible that we could, instead of doing alerts, we could take warning. If we remember, warning is this paragraph that says, please answer all questions. And we could make that now show up. So warning now, because currently warning is set to display none. But if check complete fails, instead of doing all these alerts, we could just comment out the alerts, but we could make warning show up. If we're doing that, it'd be nice to make warning big, bright, red, or some other obnoxious so the user can't not notice that something happened. The alert, by its nature of requiring participation on the user, is an annoying but effective way of getting the user's attention. Because if all we do is just put some words on screen, it's really easy if you're not really paying attention to realize, oh look, something else appeared. Or if you're, say, on a mobile device where you're only seeing part of a screen anyway. I've had instances where things are now appearing above or below where I currently am on the page, so I can't get that feedback. That makes it hard. If it was an alert on my mobile device, I would see that because it would now pop up on top of everything, so I could now dismiss it. But when I just make a paragraph show up, I may or may not see it. I make a headline show up or another div, whatever I want. A picture. But when we're doing that, so we do have to be cognizant and aware of these alternative viewing scenarios. Not everything is on a Gigantor monitor like you have on the desktop here. It can be on a small laptop, it can be on an iPad, it can be on a phone. When that happens, we have these different situations we need to take into account. So if I wanted just to have warning show up, I could just add in warning dot class name is equal to display block. That will make it show up. Because we know that when we write the story, we make the input panel disappear, we make the output panel show. Well, we can also then, if we're going to do that, you can tell warning to hide as well when we write the story. So either we hide warning or we show warning. And then I can even get rid of these alerts. So it just returns false or returns true. So I tried to go on and said, please answer all questions. Fine. Please answer all questions. Hey, look, now it worked. Go here, warning's now gone. So if you don't use alerts, it's a little more subtle what's going on. Perhaps I really need some CSS to color warning so that it has a little brighter color so that we see it when it shows up on screen. Make it red, make it big, make it obnoxious, change the font, something if I wanted to go that route. So we could use alerts, but using this method of we search through the forms and go through each one to find out, is there a value? Did they enter something in? And if they did not, this if statement will return a false value, which means this function returns a false value, so that when check complete is false, then it runs this bottom content down here. If check complete returns true, indicating they filled in the form, then it calls write story, same as it was before.